Uh, Thank you for attending my talk. This is going to be a 2-hour talk, so thank you for giving me extra time. So 75% of the talk would be about ransomware and IoT. 25% would be all about me. So this was me when I started in the industry. I had long hair. Now it's gone. So currently, I'm with the RSA. I'm the resident principal malware scientist. And before that, I was with Trend Micro, F-Secure, and Dambala, which is a company founded by Georgia Tech in Atlanta. And if you can, follow me at Twitter. And I'm also an author of 2 books, Malware Kits and Botnets, Advanced Malware Analysis. Third book, Advanced Reverse Engineering, hopefully would come in the next couple of years. And I'm also a co-author of the 2nd edition of Hacking Exposed Malware and Rootkits. If you buy those books, all proceeds go to my 2 kids' 529 college fund. So please buy them. All right, so one thing I learned every time I present is that if you tell it as a story, people won't fall asleep. And I've had people fall asleep on my presentation, so hopefully nobody will fall asleep today. So one day, a guy named Sam got an email at work. By the way, I'll go fast, so please reserve your questions at the end. And then this is what he got. So he saw this and he was saying, you know what, this is very suspicious. Since Sam went through education, user education training, he was able to say, you know what, I learned this, I'll take a look at this email and see what that attachment is all about. So the attachment is a zip file, but then when you save it, extract it, it actually looks like this. So it's not what the email was saying. But since Sam was trained, he was able to recognize this, and he said, oh, it's an HTA file. And according to the all-knowing Wikipedia, an HTA file is an HTML executable file introduced in 1999. I was born in 1999. Same with Internet Explorer 5, executed via mshta.exe. And so he was saying, you know what, I can take care of this. I can look at this. I don't need to involve any of our security team. So what he did, he was looking through the code. So what I'm about to explain here, sometimes it works on HTA files, sometimes it doesn't. So I learned this through trial and error. So I'm going to go through it in a couple of minutes, but usually when I did this with trial and error, it took me like a couple of days. So what I usually do or not me, Sam, what Sam did was, so he went through the code, and usually you would go to the end. And then you'll see some variable declarations, and then you just choose one. So here, you see this, I highlighted it, and you could see here, X key. So for me, or for Sam, it means it's probably an XOR key, so you keep that for now. And then you look some more. If you look at an if statement or any conditional statement, just get the first variable that's there, search for it, and you'll end up with a function call. And usually that function call, look for the variable in it. Usually it's at the end. Sometimes it's just this variable. Sometimes there's a plus, another variable or plus character. Copy that. Look for it again, and then you see it at the end. And then what you do with that variable is you alert on it. So you add this command line of code after the function, and when you run the HTA file, you will see something like this. It will show you the domain where it's downloading all of the malware or ransomware or whatever bad things it wants to download on your system. So the good thing about this is that you're not running it, you're not downloading the malware, it's just displaying where it comes from, which is fairly safe. So like for me, in my humble opinion, it's safe to run this in a production network, but of course don't run it in a production network. Still run it in your own isolated network. So for that specific example, these were the URLs that were revealed. So you don't need to actually run the malware in a sandbox or run it anywhere in your test machine. You just get this file here, and then you'll get the malware sample, and then you'll be able to analyze it. So that's easier said than done, right? Because once you get the malware sample directly from those domains, it's going to be encrypted. So they designed it that way so that if somebody tries to scrape malware samples from the internet, it would be hard for you to analyze it because it would be encrypted. That's where the XOR key comes from. So you just XOR it with that, with the XOR key that I showed in the HTA file, and then you'll have the executable, and then you can analyze it. They did it that way to avoid any scraping from researchers, so that if ever those samples get scraped, it will be hard for them to analyze it. So what happens in the host? It downloads file to temp folder. It's encrypted. So if you don't have the XOR key, you need to download it. You need to let it work so that you'll be able to get the malware sample. But what usually happens is that once it downloads it to the temp folder, it's encrypted. It writes it to a DLL exe file and decrypts it using the key, which is converted into a 32-byte hexadecimal. So if you visit my blog in RSA website, you'll see there how malware and ransomware uses temp folder. So what it does, it downloads there the encrypted file. It uses the key from the HTA file, decrypts it, then write it to a DLL or an exe file, injects it, or just copies itself to a different folder where it gets executed every time the system is rebooted, or after the installation, control is passed to that malware, and now it's active in your system. All right, so Sam was so happy. He said, you know what? I was able to solve it. I don't even need to involve our security team. My training worked. I can ask my employer for another $6,000 worth of training in SANS because I just proved to them that I was able to solve this problem. But of course, like every millennial like us, it didn't happen unless you post it in Facebook, right? So the next thing he did is he wanted to post it in Facebook. But then when he logged onto his Facebook page, he saw this message. So one of his friends sent him a message. It's not actually a message, but it's an SVG file. So he clicked on the picture, and this is what he saw. Like, it went to a YouTube site. You'll definitely know it's fake. I'm sorry, the picture is not as clear. But the URL is not youtube.com, so you know already it's fake. Plus, it's downloading an extension. So he was saying, I know this. I've gone through training. I know how to solve this. And he looked at the details of that extension. And as you will see, it's something that really not trustworthy. The attackers didn't even spend enough time to make it as believable as they can. So most of us here in the room would say, you know what? Yeah, everybody knows that this is easy to spot. But for non-technical users, like our aunts, grandmas, moms, dads, some of them still get fooled like this. How many of you got a text message from your relative saying, hey, you know what? I think I can pay for our vacation next summer because I just met this Nigerian prince. And he said, I just need to give him this money, and then he'll give me this amount of money. So he was saying, you know what? I need to examine this SVG file. So what is an SVG file? According to Wikipedia, it's a scalable vector graphics file. It's XML-based, and it's introduced in 1999, again, the year I was born. And the thing about it, when you open that SVG file, it's actually a red dot. So that tells me, I'm just guessing here, I'm not so sure if that's what really the attackers wanted to convey. It's like a target. So if you see a red dot, it's usually a bull's eye, it's usually a target. So it's just like saying, you know what, you got this picture, now you're marked. And when you look at it, it has a script in it, and using the same methodology that we use in the HTA file, wherein you look at the end, you look at the functions, you look at the variable. Like for this one, I just tried alerting on the different variables here until I found one that actually would display this. So it's an SVG file that points you here, which is actually the fake YouTube website that downloads the extension for you. So again, he was so happy. And he said, you know what, I'm really an expert. I was able to solve 2 targets that were headed my way. So I think I am the man. And that's it. Hope you guys learned something today. But nobody's clapping, so. But wait, there's more. I think I still have a few more minutes, so let's discuss some more. By the way, RIP to this guy. He's one of the greatest sellers on TV. So he got a snail mail from grandma. Of course, everybody loves grandma, right? If your mom says no to you, you just go to your grandma, and then your grandma would say yes. Like, I remember when I was younger, oh, there's this new Nintendo Entertainment System, and my grandma doesn't know what it is. I just told her, yeah, just give me $60, and then you'll know what it is. So usually grandmas will just say yes, yes to everything. So he usually doesn't get anything from grandma, but this time he got a mail, and his grandma actually needs help on something. So he said, you know what? My grandma's been kind to me when I was a little kid. I'll go save grandma. So he went to grandma's house, and then he saw this on grandma's computer. So everybody knows this is Cerber. By the way, when I made this presentation, Cerber was the talk of the town. You cannot go anywhere without anybody asking you about Cerber. So when you get infected by a ransomware, this is funny because some people would say, I need you to detect ransomware on my system. And I usually tell them, you'll know when you have ransomware because it will announce itself. It will play a like a narration saying you've been victimized and you have to pay this amount of money. So once it's in your system, usually it's already too late. So this is what he got. And since he has some experiences with HTA file, Sam was taking this with a grain of salt. But still, he was reading all of the instructions here. And one thing he noticed is that when you look at this, it's actually really very helpful. It will help you pay for the ransomware. And of course, everybody heard what Petya is, right? So actually, Petya changed the game of ransomware. Because before Petya, like big companies would actually pay for something so that they could get their data back. But then they realized when Petya came, they just got played. They paid for something, they didn't get anything back because Petya was actually a wiper. So it destroys your system completely. So he was looking at the README HTA. It says here, you know what, if this address doesn't work, you can always refresh this address right here. So let's say you're still thinking 2 days, 3 days from now, you're still thinking, you know what, okay, I'll pay for this because these files are important. And then you find out that this link doesn't work anymore. You could just refresh it and then it'll give you a new link. And usually it says here that the HTA file is, with your encrypted files are not viruses. So the HTA file, it's saying it's not a malware. But of course, if it's coming from a threat actor, you always take it with a grain of salt, right? So if you're not sure what it is, make sure it's, be careful all the time. So the good thing about Cerber is that it has a decryptor. And again, we played around with this. Their customer service is actually way, way better than real customer service. How many of you talk to your phone provider or cable provider wherein you have to wait a long period of time on the phone, 45 minutes to an hour, send them an email, wait a week or so, you don't get a response. But Cerber, they're really very responsive because they want you to pay. Like you are their customers, so they want to make you happy. And then they're also very security conscious, so you have to prove you're human when you're contacting them or want to talk to them. And then they offer you like a discounted rate. It's available in the next 4 days, 23 hours. And this is what I was talking about, that tech support if you have problems. And the good thing about Cerber is that it gives you the opportunity to try before you buy. Like it's a very proven thing when you want to sell a product. Like in the US, they would say, you know what, you can buy this. If 30 days you're not happy, you can return it. Some stores actually offer a year. Some stores even offer a lifetime. But of course, for them, they just say, you know what, we'll give you the opportunity to decipher one file. So the good thing about it is that when it comes to grandma's computer, she really doesn't have any files on her computer. She only has one picture file. Because most of her pictures are either on albums or on the walls or on top of a mantle of a fireplace. How many of you, when you go to grandma's house, it's like a museum, right? You open the door, like tons of pictures there, pictures of your aunts, your parents when they were young. And then you go upstairs, there's pictures lining up the wall, going up the stairs. So all of the pictures are there. So Sam was saying, Grandma, it's good because you only have one picture. You don't need to pay for anything. We could just use this, their sample to decrypt your picture. Then you don't need to pay for anything. So when it comes to decrypting it, you just upload it, and then after a few seconds, couple of minutes, you can download the decrypted file. It's offered as a zip file. Then they save it and then open it. So this is what a decrypted picture file looks like. Now this is my test JPEG file. As you can see, I just put everything like A there. Sorry, this is the encrypted file. And this version of Server only decrypts from the 640th position down. So it only decrypts that part. And I know when it gets decrypted, it has to go back to A all the time. So the decrypted file looks like this. So the thing about not only Server, but other ransomware, when they decrypt files, they're actually putting it back to its real previous state, everything, to the last bit, even to a date created, date accessed, date opened. It puts it back to how it was before. It's better than an insurance company, right? So when you have an insurance company, they will say, oh, when you get damaged, we'll put it back to how it was before, but actually they won't be able to do that. But ransomware, they're able to do that. They'll actually return it back to the previous form it was without, so you won't even know that something happened. So if you're a traveling executive, you got victimized by a ransomware, and you decided to pay for it, your boss wouldn't know that you got victimized by ransomware because everything would be back to normal. So he was saying, Grandma, I'm just curious, what's that one picture you don't want us to see, and you're not even printing it, it's just on your desktop? And this is the picture of Grandma and Grandpa. By the way, they're not my grandparents, they're my neighbor's grandparents. So I had to cover their faces. So words of advice. So for us, this is common sense. But given my experience with other clients and with people that are not really that technical but has access to things that will enable malware to move laterally in their organization, this is still helpful for them. So don't just click on anything. If it's too good to be true, chances are it's not. And back up regularly. So most user education usually starts with this. So for us, it's already common sense, but unfortunately, for most people that gets victimized, it's not really common for them. So Sam was happy, and he said, you know what, it's late, I need to go home, my girlfriend's waiting for me, she's a night shift nurse, so she's probably waiting in my apartment. So he got home, and he said, you know what, I just want to relax and chill. So I'm not so sure if in Amsterdam, Netflix and chill is a thing. I don't know what it is, so I just heard it yesterday. So, and then said, you know what, let's just Netflix and chill. Let's put on the first episode, season 1 of Game of Thrones, where we see Khaleesi expose herself. So, but then he said, you know what, nothing is working. It's like, I wanted to relax with my girlfriend. I'm tired from helping grandma and solving 2 malware problems, and nothing's working. So he tried other services. He tried SoundCloud, Spotify, Twitter, PayPal, and nothing was working. Everything was unreachable. And then, as the day unfolds, Sam found out the cause of the outage. There was a botnet going around called Mirai. It's a DDoS botnet. And the signals or the packets are not coming from your regular desktop or PC or systems. It's coming from devices. So what is Mirai? So it's a malware that infects IoT devices for the purpose of using them in DDoS attacks. So it spreads by scanning IP addresses to find vulnerable IoT devices. And when it comes to scanning IP addresses, it excludes IP ranges of General Electric, HP, the US Postal Service, Department of Defense, and IANA. I would understand they would skip DoD, but I'm not so sure why they would skip the other companies here. I'm not so sure what the tie is, but it's interesting. And it also uses a remote CNC to determine its DDoS target. So you could actually change the target based on the command it gets from its CNC channel. And when you look at the code, this is the IP address exception list. So if you want to modify it, if you're playing around with it, you don't want your company to catch you, just put your company IP range there, and then it would skip it. So how does the attack work? So once it finds vulnerable IoT devices, it brute forces its way into accessing it via a list of common passwords. And then once it infects an IoT device, it makes sure that nobody can communicate with it by closing SSH, Telnet, and HTTP ports. It also looks for and removes another IoT malware by the name of Anime. So the good thing about analyzing malware is that if it's a malware that is competing with another malware, chances are it would have the code on how to remove that malware, which saves us time. Because you don't need to reverse that other malware. You just need to get the code from the competing malware, try it out, and if it works, it works. Similar to during the SpyEye and Zeus war during the olden times. So this is the list, the list of common passwords. So I have all of this because the Mirai source code is already public. So the good thing about source code being public is that I don't need to reverse it, just read the code. But then, of course, it's a double-edged sword. If it's available there, somebody can improve it and release a better version of it for their own purpose. So this one, it's Anna Senpai is the one that's claiming that she's the author. So senpai is actually a Japanese word for upperclassman. Usually before sensei, you become a senpai. And then when you're already an expert and you're able to teach other pupils, then you become a sensei. So I'm not so sure if there's another sensei on top of her, but for now, this is what they're claiming. So since the source code was public, somebody took that code and attacked Dyn. So Dyn is an internet infrastructure company. It's in New Hampshire. And the first wave started at 7 a.m. Eastern. So that's 7 a.m. in New York and in Atlanta. Second wave around noon. Third wave started around 4 p.m. So they were trying to do Netflix and chill in the morning. That's why they're not able to access any of the services they want to access. So all of the traffic to Dyn's Internet Directory servers caused it to stop. So the DDoS there for millions of IP addresses or for millions of IP devices. So if you have a camera at home, usually when you look at it, it says some cameras have a default broadcast. Like for me, I have cameras at home. It has default broadcast. I make sure I turn it off because anybody that knows the IP address of my camera can see what my camera is seeing. And I usually put my camera in our guest bathroom. So Mirai, what happened? September 20, 2016, Krebs' website was DDoSed. Mirai source code was leaked. Dyn was DDoSed. And then after Dyn was DDoSed, Oracle bought Dyn. So it's a good business practice. And then Krebs identified the alleged Mirai author. But of course, in our world, any digital evidence can be faked. So even the source country can be faked. Everything can be faked. So for you to not be a victim of Mirai, by the way, Mirai just, a new wave just came out, I think like a week ago or a few days ago. I haven't really looked into it yet, but it's still around. So change default username and password, disable unnecessary remote access to the IoT device. If you just want your phone or your desktop to access it, make sure it's the only device that can access your IoT device. Device. And US Cert Advisory, I have it here. It's long. I won't read it. Once you have a copy of the slides, you can just go through it. So here, it's a mouthful. It's long. You have to memorize it. So, and then Sam realized, you know what? I haven't been doing this. So he said, you know what? Just give me a couple of minutes and I'll make sure I put those practice into use. And then this is what he saw. So this might be the future. You might have an IT device that's victimized by ransomware and say, you know what, I won't turn on your heater unless you pay me this amount of money. Or I have pictures of you in compromising positions in your camera and I will sell this if you don't pay me this amount of money. So Sam was saying, this is going to be a very long day. The end. Oh, by the way, any questions, violent reactions? Yes, sir.
So you were talking about the ransomware and that they have this great customer service and that they do everything to get your money. They help you out a lot. So what changed with Petya?
So with Petya, the thing about Petya is it's really not ransomware. I term it as a wiper. Because what it did, at first it shows message like you need to pay this, and your files have been encrypted. But then when you look at the code itself, there's no decryption capability. What it does, it actually messes up your master boot record. So once you get infected by it, if you don't have a backup of it, then you won't get your files back. And it actually, this is from the chatter from the underground. It actually messed up the other ransomware operators and it made them mad because now the customers are losing trust on them because they're saying, hey, we have this really nice business model and Petya came and messed it all up. Now, how will the public trust us? So that's what they're saying.
Any other questions? Yeah.
Thanks for your talk. I was wondering, you have been working for several antivirus companies, and I'm by no means a malware expert, but I was wondering why have we as a antivirus industry still not solved the issue of, well, crypto lockers? Like, we have a lot of behavioral and heuristic detection mechanism these days. How come that major antivirus systems like, for example, McAfee antivirus security still has not been able to, well, detect most of these cryptographic operations and read-write instructions and those kind of things in malware?
So it's not only the cryptographic malware, it's basically malware in general. So I had a presentation before, I call it the malware factory, wherein I showed live how easy it is to create a new generation of malware. And the thing about usually host-based systems, they would rely on host behavior. They would monitor the environment, and if there are changes, they would use that as a signature and the static signature of the malware file itself. And the thing about it is that if you rely on signatures, you can just change one thing, and then it would totally be different. So in my presentation, the malware factory, I proved there that I just changed one thing, and it's a totally new malware again. I actually call it the green malware, made of 100% recycled malware. So it's the same thing, no matter what, even if it's a crypto locker or whatever. They just change something there, they deploy it, and it becomes new again. So right now there's a movement when it most host security systems are using machine learning. But of course, we're still far off from achieving that. There was a case, I won't say the names of the company, wherein a researcher uploaded Hello World in VirusTotal, and some machine learning algorithm of host-based systems detected them as malware. So right now, when it comes to detecting malware, there's so many things you have to insert your product in, which is why the presentation about the kill chains earlier is very helpful. Because once it's already in the host, it means that your network defenses already failed, and if it's able to install itself on the host, then your endpoint system has failed. So unless we find a new way of detecting malware that's not signature-based and a better AI or better machine learning algorithm, malware will still thrive, which means job security for all of us. So I hope I answered your question.
Yeah, partly.
All right. By the way, when I started in the industry, we were only getting like 13 bytes from the malware code. Before it was enough because it was just DOS malware. But then when Windows malware became a reality, everything changed.
A very quick one. You talked about, the grandmothers that, looking at ransomware and they don't know what to do. And you get all these people that they don't know how to use their computer. This is what they say. At the end of the day, they know how to go out, buy Bitcoin, and pay for the ransomware. So I don't see how this thing to relate.
Oh,
I mean,
yeah, that's right.
They can't go out there. The malware authors expect them to go out, buy Bitcoins, and pay them. And these people don't know how to open Facebook if it shuts down differently, if they're logged out, for example. So I cannot see, this is a little bit of a philosophical question, but I think there is something there.
That's actually a very good question. So when it comes to ransomware, most of their targets are actually big companies that have like multi-million-dollar IP on their system. And they have that capability to buy Bitcoins. Before, there's a wave of, I would say, fake ransomware, scareware. I actually had a presentation about it. I call it All Your Macs Are Belong to Us, wherein their targets are really like the non-technical users. They make it very easy for you because they would even have an instruction there. Just go to Walmart, buy this card, input your 16-digit card here, or you can use your credit card to pay for it, which is easier for most of our non-technical relatives. So it's easier to go to Walmart or go to Western Union, MoneyGram, and send money, or buy those prepaid cards. And like right now, there's an IRS scam that's been going around again. It's an old scam, but it's funny because they would ask you for, how about you just pay me in iTunes card, or how about you just pay me in Google Play cards? And
it would be more convenient if they were asking those things instead
Yep.
of, go buy Bitcoin.
Yep.
What Bitcoin is, and you have
Yeah.
24 hours to do it.
which is true. Like unless you've been exposed to this, you wouldn't even know what a Bitcoin is.
There is a business opportunity there. Cards for ransomware,
Yep. Yeah.
Okay, we need to stop this because we need to have a break. There is the workshop also going on next door if anyone wants to go and join and have a look. But yeah, thank you so much.
Yeah. Thank you, guys. Thank you.